Welcome to the week 3 live session video. So this week we'll be looking at exponents. These are my dogs, Wally and Eva here. So what's due by Sunday night, you have a quiz and a test. Just like in week 2. So we'll just get started. Always forget to turn on my drawing pencil. So we know what exponents are basically. We're probably familiar with them. This is 4 squared. So this is what we call the base. And this is the exponent, or the power. So we have 4 squared. That means 4 times 4. And we can evaluate that and find the answer. So that's 16. Here's another one. 2 to the third is 2 times 2 times 2. So the exponent tells us how many times to repeat the base. And 2 times 2 times 2 is 8. So we also can do that to a negative number, negative 2 to the third. So the exponent tells us to repeat the base 3 times, and it's always multiplication. And then that equals negative 8. So if you have an unknown number, like x to the third, that's x times x times x. And we don't know what that is, so the best way to simplify that is just x to the third. I mean, this is kind of silly to write what I did, but it's just for explanation. So let's see. Problems that you'll see are like these. So we have negative 3 squared this way, and we have negative 3 squared this way. So this is a problem that's very short and seemingly simple. You can look at it and think think about what the answer is. And now I'll tell you that 99% of students get this incorrect until I explain it, and then you got to remember it. So like I explained with the negative 2, this negative 3 squared is saying to repeat this base 2 times. And so once we write that out, we clearly see that's a positive 9. Now here, this 2 is an exponent for only the 3. So this negative is like a negative 1. You can look at it that way. And the 3 is repeated. So once you write that out, you see what you have. And that's actually negative 9. So you'll see this within problems and with unknown variables as well when you're plugging numbers in for unknown variables. So I don't know that you'll see this just by itself, but we definitely build on to this. So you can pause the video and try these two. Try not only finding the answers, do that over here or on your paper, but writing out this intermediate step for each. What does it look like? And then compare it with mine. So for negative 5 squared, that means 2 negative 5s are multiplied together or repeated. So that's clearly a positive 25. And then for this one, that's a negative 1, and only the 5 is being taken to the second power. So that's a negative 25. Okay, so you got to remember which is which, not by memorizing, but by knowing what exponents mean. So if we wanted all the negative 5 to be squared, we would put our hands around there, grouping like. That's what parentheses are for. So that's how we write that up here. But down here, no. If we didn't want all of that, we wanted that quantity to be negative, this is how we would write it. We have no other way to do it. So these intermediate steps are the most important because the answers are the easy part then once you get the intermediate steps. So it's about understanding these concepts, not memorizing which is which, or else you're going to forget and get it wrong, and in the next math course you'll forget. And it's very short and easy and not bad, not difficult for, of a concept to understand. Now here's some more of the types of problems that you'll see. 2 squared times 2 to the third. So one thing I can do is write out, I have 2 times 2 for that first 2 squared, and then times 2 times 2 times 2 for that 2 to the third. So that's the same thing then as 2 to the fifth. And of course, that's 32. So you can do that with any number, any base and any exponents. We could have just skipped that step and gone to here, where we take the exponents and add them. And of course, if they're numbers, we go ahead and evaluate it, because we can. We can take the calculator or write it out and do it. But we can add the exponents. So when you have the bases that are the same, you can add the exponents. So if there's unknown variables, here's the base. All you need to do is add the exponents, and x to the fifth is your answer. So 32 is the answer here. We don't know what x represents, so that's it. So also you can go ahead and write out 2 of those x's, then times 3 of those x's being multiplied together. And that's the same thing as x to the fifth by definition anyway. And so you can take a shortcut and add those exponents. Let me see what I've got here. Okay, so that's actually called the product rule. And that means that, I'll just make a different example here. We have something like x to the fifth times x to the seventh. You can add the exponents. X to the 5 plus 7 equals x to the 12th. And you put on your paper whatever examples that you want. Usually we use A and M and N for general terms, but this is good enough. You can put a number example here too. Circle things, arrows, write words on your page. Pause the video so you do that, and you have good notes for yourself next to you for the quiz and the test, and you'll ace it then. So we have these different exponent rules. The first one's called the product rule. Product because multiplication is product. Product's another word for multiplication. We're multiplying the bases, we can add the exponents. So here's some more of these. Now you can pause the video and practice these if you want, and write out what these would equal. Take the shortcut step, and then check with me if you want to do that. So this would be y to the 7 plus 5. I guess I used 7 plus 5 just now, and that's y to the 12th. So you might be given problems like this and you just write the answer. So this is a to the 4 plus 6. And you can write out 4 a's and then 6 a's and see how that's actually 10 a's. But after a while, we just, don't need to do that. And if we had a big number in the exponent, we wouldn't want to do that. Write out all of those. Now here, if you notice, the bases are not the same. So the answer is just this. That's all we can do. Now we take a look at division. We looked at multiplication when the bases are the same. Now we'll look at division when the bases are the same. So if I have 2 5s on top and 2 5s, 5 2s on top and 3 2s on bottom. Okay, so what I can do with division when there's multiplication between things is cancel 1 on top with 1 on bottom because they equal 1. 1 times all of that is just all of that. And what I have left is 2 times 2, which is 4. And another way you could look at it is if you subtract the exponents. Since the bases are the same, and you subtract the exponents, we'll have 2 squared, and that's equal to 4. So you can also just subtract the exponents. And that would be true with if the 2 was any other number, any real number, and the exponents were any real number. You could make up a problem and take a look at it just by writing it out. Now with x's, I have 9 x's here. And then I have 4 x's on bottom. And so I can cancel 1 on top out with 1 on bottom. See that? And what I have left is 5 on top, or it's over 1, you could say that too. So x to the 5th. Or you could just subtract the exponents. The top exponent minus the bottom exponent. And so 9 minus 4 is 5. So we can take a shortcut this way as well. And that's called the quotient rule. Quotient means division. So when you're dividing the exponents, I'll put it in terms of a then. A to the third over a squared. For example, we'd use m and n. That's the common general way to write this, but that's okay. So a to the 3 minus 2 is what you can do, which is a to the first, which we just write a. We don't really write that 1. So there's an example there with your quotient rule. So we have the product rule and the quotient rule so far. So when the bases are the same and you're dividing, corresponds to subtraction. So you can, if you're dividing the bases and they're the same, you can subtract the exponents. Now we have some problems where we'll have both of those rules mixed in. So here's an example on top here. So most people, there's usually a couple ways to do these problems. Most people will go ahead and simplify the bottom first. So if we have x to the 4th times x squared, you know it would go here. We add the exponents if the bases are the same. So that's x to the 6th. And really anything divided by itself is 1. So you can just write 1 there. And here, we'll evaluate the bottom. And we have a to the 4 times a squared. So we can just add the exponents. So 4 plus 2 is 6. And then we can write out 8a's and write out 6a's and cross them out and see how many's left and where it is if you want. Or you can just take a to the 8 minus 6 since the bases are the same. And that's a squared. So a squared is the answer for that. Here's a couple other problems, and you can pause the video and try these if you want and see how you're understanding. So here we have the x's. We have to look at which bases are the same. So the x's here can be evaluated. So you have 10 on top, 5 on bottom. So you have 10 minus 5, which is 5. So you don't divide them. And then the y's too. You're not going to have any x's or y's left on bottom. So with the y's, you have 13 minus 9, which is 4. So x to the 5th, y to the 4th is your answer. So you have to slow down and make sure, even though there's a big division bar here, you're dividing the bases, but you're subtracting the exponents. So 10 minus 5 is 5. For this problem, I'll go ahead and write a squared be the third in the bottom because we'll evaluate the top. So there's all multiplication going on between these things here. We really don't need parentheses. So with the a's, we have a to the 7th, a to the 3rd. We add those exponents. That makes a to the 10th. Sorry about my throat. And then b, for the b's, we have 2's as the exponent. 2 plus 2 is 4. So I need to write this step down so my brain can see it and I can get the answer correctly. So now we have a's here, 10 a's on top, 2 on bottom. So I really don't need that division bar, I guess, because I have more b's left on top as well. So I'll have 10 minus 2 is 8, so 8 a's left. And with the b's, I have 4 minus 3, and that's 1. So we don't really write that one, and so that's it. But you should have multiple choice. Also, you should be able to pick the answer out in your quiz and your test. And now a totally different kind of rule, which is negative exponents. So what you do when you have x to the negative third, the best way I can describe it is this. Anything, any number, really is over 1. Same thing. You actually simplify this, but we're expanding it sort of just to recognize the upstairs and downstairs. And when you have a negative exponent, that's saying I want this whole thing to go down. So what happens is the x goes down and the exponent becomes positive. And if there's nothing left, it's a 1. So the answer is 1 over x to the third. And so let's look at this one. This is really over 1. Anything's really over 1. So you might want to start with writing that at first when you're getting used to this. 2 to the negative third over 1. And so you want to move that down because the negative exponent is telling it to move, so that becomes 2 to the third. And then a 1's left on top. And since that's a number, we must evaluate it. So that's 1/8. And it's sort of like one instructor I saw explains it like this. Like if something wants to move downstairs, it's holding out like an elevator ticket, as if there's tickets. And so when it goes downstairs, it uses up its elevator ticket. There's no longer an elevator ticket. So that's one way to remember that the exponent becomes positive. So let's see what else we got. So here's y to the negative fifth. You can try this 1. I've got to explain this probably. But you can try this 1 and pause the video and see how you do. So this is really y to the negative fifth over 1. And so this is saying I want to go downstairs. I want to take this whole term downstairs. That becomes y to the fifth. And there's 1 left on top. So that's it. Now for 1 over a to the negative fourth here, this is already downstairs. It's just saying it wants to go upstairs. So it becomes a to the fourth and 1's left on bottom. And anytime something is over 1, we go ahead and simplify that. We never leave it that way. So a to the fourth is the answer. So guess how this one would work out? A to the negative third over b to the negative fifth. So this one wants to go up and this one wants to go down. So it'd be b to the fifth over a to the third. And that's it. And that's how negative exponents work. So here's a problem that you might see that I've seen show up on your quiz or test. Negative 3x to the negative fifth. So we've got something with the negative exponent. So remember, any answer that you see in multiple choices or in your work that has a negative exponent in it, that's not the correct answer. That's not going to be it. Anything with a negative exponent has more work yet to do. So we never ever have a negative exponent in an answer. So here, this wants to go down. So you can put all this over 1 if you want to begin. And see that this whole thing wants to go down. So the negative 3 stays on top. Nothing's telling the negative 3 to move. So this becomes x to the fifth on the bottom. So this is the same as putting that negative outside here too. You can do that. You might see the multiple choice answer like that. But remember, negative 3 is just a negative 3. It's not a negative exponent, and it's not being taken to the negative fifth. Only the x is. So only that moves down. Next concept to remember is that anything to the 0 power equals 1. So a 3 to the 0 power equals 1. Isn't that strange? You would think maybe it's 0. A 7 to the 0 power equals 1. An 18 to the 0 power equals 1. Anything to the 0 power equals 1, and that's something for you to remember. 100 to the 0 power equals 1. If I had a whole negative number here like this, negative 2 to the 0 power, that equals 1. So your job is to remember that anything to the 0 power equals 1, okay? So I've seen this in your quiz or test as true-false questions, so that you might have 5 to the 0 equals 1 written there. And then is it true or false? And you have to select which one. Well, anything to the 0 power is 1, so that would be true. Okay? This one even though I have an x through it. And then I've seen it also like this, 17 to the 0 power does not equal 1. So when we put a slash to the equal sign, that means does not equal. Well, what we know is that anything to the 0 power equals 1. So you're asked, is this a true or false statement? So it would be false for this one. So this is how you'll see these problems. And I'll just explain why a little bit, because it's easy enough to explain. Sometimes things are not simple explained, so we skip the why for now. So say we have, I suppose, x to the 5th over x to the 5th. So that's 5x's on top. There's a couple ways to look at that. That's 5x's on top. You know, and you know anyway that anything divided by itself equals 1. But even if we cancel everything out, nothing's left. That's 1. But also if we use that quotient rule that we know, where we just subtract the exponents, that equals x to the 0 power. And so therefore we conclude that this equals this. So x to the 0 equals 1. And you can put a y in there, an a, b, and use any unknown variable, and that'll be true. It'll be the same thing. Doesn't change the pattern going on. So if we had 3 to the 4th, we use the numbers now, divided by 3 to the 4th, that's just 4 3's multiplied together. And remember, anything divided by itself is 1 anyway. But we can write out, there's a few ways to look at this. So we compare those different ways, and this is how we come up with these rules. And then they all cross out because they equal 1. 1 times 1, I mean, it's all just 1. Or you can subtract the exponents using that quotient rule of exponents. So 4 minus 4 is 0. So you have 3 to the 0. So that's how we conclude that 3 to the 0 equals 1. And you can put it in your calculator. Put any number in your calculator. Play around with that. Put 5 to the 0 power, push equals. And everything's 1. The calculator knows that. And what else did I want to say? So any number here, you could use any number, real number, 100s instead of 3, any number for an exponent, and this whole pattern would simply happen. You can write some other numbers, examples out, and see how it works, and compare it just to see if you wanted. But anything to the 0 power is 1. Now we go to something totally different. Switch gears, which we're looking at polynomials. So I'm going to give you some examples of monomials, examples of binomials, and trinomials, and then polynomials. So examples of monomials are just 4x or negative 2y, even just x is a monomial, even just a number is a monomial. What else? 2ab, maybe you'd see, maybe x squared or 3x squared or something. These are all monomials. There's one term. Okay, terms are separated by plus or minus. So with binomials, something like 4x minus 1 is a binomial, x plus y, because there's two terms. So binomials, and terms are separated by plus or minus. 7 minus a, x squared minus 36. These are all binomials. 9 minus b squared, I don't know. So trinomials are 3 terms. So x squared minus 2x plus 1 is a trinomial. Terms are separated by plus or minus. Y squared minus z minus 9, anything like that is trinomial. 2x squared plus 5 minus a. You can make up anything, you get it? So tri means 3, so trinomials. Now polynomials, all of these are polynomials. But also if we had something like xy minus y plus z minus 5, and these are all unlike terms, of course, you can't combine them. Well, that's when we get to 4 or more terms, we just call it a polynomial. So you can write that in 4 or more terms. It's just a polynomial. All of these are polynomials as well, but these are specific different ones. So in your quiz or test, you'll be given an expression and you'll be asked in multiple choice, is it a monomial, binomial, trinomial, or something else, or neither, or something like that. So here's an example right here, 5x minus 2. So is that a monomial, binomial, or trinomial? So that would be a binomial. There's 2 terms. So you have problems like that. And then over here, look at this, at y squared minus 5x plus 25. Is that a monomial, binomial, or trinomial? And of course there's 3 terms, and that'll be a trinomial. We cannot combine them. There's no like terms, so that would be it. If we can combine some terms, then you go ahead and do that. So here's another thing, this concept of the degree of a polynomial. So this is a crazy big problem that helps me to really explain it, and then I'll show you what a problem looks like that you'll get. So we have this big, long, crazy polynomial, and we're going to find the degree of the whole polynomial. So first, what you can do, which I'll just educate you on, is finding the degree of each term first. You don't really have to do that to find the degree of the whole polynomial, but this is, you'll see how this works better. So the degree of each term is designated by the exponent. So the degree of 5x to the 8th is 8. I'm going to write the degrees right under each term. The degree of negative 6x to the 7th is 7. You see that? The degree of this term is 4 because the exponent is 4. The degree of this term is 3. The degree of this term is 2. Do you know what the degree of this term would be? There's really a 1 right here that we don't write. It's just shorthand to not write it. So the degree of that term is 1. And the degree of any number is 0. So what we do sometimes is identify the degree of the whole polynomial. And what we do is we take the term's highest degree, the term with the highest degree, and that's the degree of the whole polynomial. We don't add all of these. We don't add them. It's kind of intuitive maybe that we would add, but no. This number actually tells us a lot of information about our polynomial, which we would build upon in future math courses. And so repeat that, replay that part if you need in the video. But here's an example problem. This problem, I didn't write it, but it's going to ask you to classify what does it do? They're going to ask you to classify whether it's a monomial, binomial, or trinomial. And same thing with the problem on the bottom. And then they're going to ask you to tell the degree of the whole polynomial. So this one is a binomial. And this is a trinomial. Okay, now the degree of this term is 2, and the degree of any number is 0. And remember, the degree of the whole polynomial is the degree of the term with the highest degree, so that's 2. So you really don't even need to pay attention to this lower one. Just look at the highest exponent and you got it. And how about this one? Can you tell what the degree is? Do you know what would go right here, the degree of the whole polynomial? I don't know why I wrote that so low, this whole line. The degree of this term is 3, and just to practice, the degree of this term is 1. The degree of this term is 0. So the degree of the whole polynomial is 3, the highest one. You really just need to look at the highest exponent. Later in math courses, we call that degree, but we also call it roots, zeros, x-intercepts. When you actually graph these things, you'll see that's how many times it crosses the x-axis, and those points are very valuable in real application. And so it's funny though, that's all we do with this in this course, but that's where we would be going with that later. And so now we're going to multiply these things, multiply binomials. So if if you're looking at x minus 3 squared, what you have to remember is up to you to remember is this is the base, and the exponent is telling us to repeat this 2 times. And then we can use what's called FOIL, which helps us to organize our distributive property. You might have heard of that before. So I'm going to use FOIL to multiply this out. FOIL stands for first, outer, inner, last. So the first positions are here, x and x. So x times x equals x squared. This is how we multiply this. O for outer. Outer is the x and the negative 3. So we multiply those. X times negative 3. That's negative 3x. And then the I for inner, and that's these terms here. So we're multiplying negative 3 times x. And that's negative 3x. And then L for last is negative 3 times negative 3. And so that would be positive 9. And what we do then is line these up. X squared minus 3x minus 3x plus 9. And these are like terms. Sometimes you'll have like terms and you must combine those. So x squared minus 6x plus 9, and that's it. This is your answer right here, as long as you can't combine anything else. So when you multiply this, it looks like this. We cannot distribute this 2 to each term. We have to remember what exponents means. Take the base and repeat it twice, multiply it twice, and then you can see that you'll have FOIL to use. I'll do another one like that. So remember, this means 2x plus 2y times 2x plus 2y. So I've got FOIL to use. So you might not need to write down these letters like this. You might be able to do this a little faster. It depends. Now, one thing I highly, strongly suggest is go into my math lab and find these problems and do a lot of them. It's going to help. You're going to start to get really good and faster. It should be slow at first and then go faster. And you'll start to see patterns because we're going to be factoring these. And that's very important to know how to multiply these forward, sort of forward, in order to be able to go backwards and factor them. That's one of the most important types of problems to practice a lot of. Okay, so the first positions, F for first is 2x times 2x. I'm just going to write this out in case somebody needs it. So that's 4x squared. The O for outer is 2x times 2y. And that's 4xy. The inner is 2y times 2x, so basically the same thing. We write this in alphabetical order. So 4xy. And L for last is 2y times 2y. So I write 2y times 2y, and that's 4y squared. And remember, what we do next is write these out. 4x squared plus 4xy plus 4xy plus 4y squared. And we have like terms right here to combine. So it actually is 4x squared plus 8xy plus 4y squared. And that's it. That's what 2x minus 2y squared equals. Remember, you cannot just distribute that 2 to each term. You have to write that out and see what you've got to work with here, and then use FOIL. You might be given some of these in true-false types of questions, so you must FOIL it out, write it out, and see if that's true, what they have there. So here's a different type of problem that you'll see, and a lot of students miss this when I go back and look at the quizzes and tests. So here you go. Here's a good explanation for you. 3AB, oh, this is supposed to say is here. Is 3AB the GCF, the greatest common factor of all of these? Now these are 3 terms here with commas in the middle. So the first thing we do is look at the numbers, the 3 and the 6, the 15 and the 18. And we have to think what is the greatest common factor of 6, 15, and 18? Is it 3? So you sort of start with the 6, and 6 goes into 18, and that's good, but 6 doesn't go into 15, so 6 isn't it for all three. So the next factor down within 6 is 3. So does 3 go into each number? 3 goes into 6, 3 goes into 15 evenly, 3 goes into 18. So 3 checks out. So the GCF that it should be is 3. Now we look at the A's. So here's the A's. This one has 2 A's, this one has 3 A's, and this one has 3 A's. And so what we're asking is how many A's, what's the maximum number of A's that each term here has in common? What's the maximum, the biggest number that they have in common? There's 2 here, there's 3 here, and there's 3. There's 2 here. This one does contain 2. This one also contains 2, but this one doesn't contain 3. So 2 has to be it. A squared is the greatest common factor as far as the A's go. That's what you ask. What's the greatest number that they have in common? Same thing for the B's now. We got to check the B's. So already I can see this question is false because it's saying 3AB is it, but A squared it should be. So with the B's, here's the B's. This one has 2 B's, this one has 2 B's, and this one has 3 B's. And you have to ask, what's the greatest number of B's that each have in common? This has 2, this has 2, this has 3. So they each have 2 B's in common. So that's totally false. So false is the answer for this one. So 3AB is not the GCF. This is the GCF here. Okay, so that's how you go about it. Look at the numbers, think about it first, then the letters, one by one. And if you need to write in words what you do, because you're going to need an example on your page when this comes up, you can look at your notes and do that problem correctly. Now we start to go backwards and factor. We're multiplying things. The previous problem was the beginning of factoring, but we were multiplying things. Now we're going to start dividing things out or reversing that multiplying, doing the opposite of multiplying, which is the distributive property. So we look at 15x squared and 45x, and we start with the numbers. We want to think of what's the greatest common factor of each. In fact, does 15 go into 45? Because what I'm going to do is take out my greatest common factor right here and write what's left in here. So 15 does go into 45, so I can take out a 15. And a 3 would be left here. So I'll explain that in a second. I'm going to move this parentheses over a little bit, and then I'm going to look at the x's. And I ask myself, this one has 2 x's, this one has 1 x. So what's the greatest number of x's they have in common? And that's just 1x. They both have 1x. This one doesn't have 2 x's though, but they both have 1x, so I take 1 out. So 15x can come out, and that's my greatest common factor. Now what I do to write what's left is 15x times something is going to give me 15x squared. And that's an x that's needed there. 15x times x is 15x squared. And then 15x times something is going to give me negative 45x. And I already have the x, so I need the 3 because 15 times 3 is 45, but this should be x minus 3 then. So just to write it neater, 15x times x minus 3 is the answer. And what you're always doing is multiplying this back, 15x times each term inside the parentheses, using the distributive property to make sure it matches the original problem. You think through it and you're always multiplying it back, and then at the end you multiply it back again just to check. And that's how to factor. Now for this problem is a little different. We don't have anything in common with all 3 at all. We don't have an x in common with all 3. We don't have a number in common with all 3. So what I want you to do when you see your classic trinomial setup, x squared, an x term, and a number, is to write 2 sets of parentheses. And this is how I go about that. If you want more on factoring like that previous problem, you can definitely look at factoring expressions on YouTube and get a lot of examples. Also, my math lab has a lot. So this is how to factor this. So we start with this term. We're going to need x and x here because those first positions gives me x squared. That gives me that position. X times x is x squared. Then what I do is I jump to this number here and I consider all the factors I have to work with 25. I have 1 and 25 and I have 5 and 5. Because I'm going to put a pair of those in here, either 1 and 25 or 5 and 5. I have to pick the pair now that when I multiply them, I get a 25, but when I add or subtract, I'll get a 10 of some sort. And that's going to be the 5s. So I'm going to put the 5s in here. Just throw them in. Now I have to consider the signs last. I need a positive 25 when I multiply the 5 and 5, but I need a negative 10x, and that comes from adding the inner and outer terms. So I'm going to try minus and minus. It has to be plus or plus to get positive 25, or minus and minus, right? If I had plus and minus, that wouldn't get me a plus 25 or positive 25. So this I'm claiming is the answer. But all I got to do is FOIL, first, outer, inner, last, which I'll do really quick if my internet will allow me. And just check that I factored it correctly. First, outer, inner, last. These are alike, and those will make negative 10x. So yeah, that matches the original problem. So this is the answer. I got my signs right and everything then. So I'll do another one like that. X squared plus x minus 6. So first I check if there's anything in common with all three terms that I could just factor out of everything, and there's not. So I see my classic trinomial setup. You know, that's what I call my classic trinomial setup. Squared x squared and an x term and a number. So I'm going to draw my two sets of parentheses, and the first thing to get this first term is x and x. That's always the easiest part. Throw an x and x there. Do you remember what I do next? I jump to the 6. And I think of the factors I have to work with 6. I have 1 and 6 and 2 times 3. And I'm going to put a pair of those right in here. I have to pick the pair that when I multiply them, I get a 6. But when I add or subtract, I get a 1 here of some sort. And if I add these, I'll get a 7. If I subtract them, I'll get a 5, but I'll get a 1 out of this. So I'm going to throw in 2 and 3, and I consider the signs last. I need a negative 6 when I multiply these. So one's got to be plus and one's got to be minus. And I can just throw something in and try it. You'll start to see what works without just throwing them in, but you can always FOIL. So I'm thinking this is the answer, but I need to check. So I'm going to use FOIL to check. So first positions gives me x squared, outer is 3x, inner is negative 2x, and the last position is negative 6. These are alike, and that gives me positive 1x. Don't really write the 1. And it's the same as the original problem, so yes, I factored it correctly. And that's how I go about those. I think I've just got a few more to do. So now we'll factor this one. 2x squared plus 2x minus 12. So first I look to see if there's something I can factor out of all terms. They're all are all even numbers I can factor out of 2. So what would be left is x squared plus x minus 6. Okay? So if I multiplied the 2 back, I could check that I did do that correctly. Next, here's my classic trinomial setup. So I'm going to try to factor that this way. I'm conditioned now, you know. I have an x squared term and x and number. I want to try and factor it. So x and x goes in here. And I think we just factored this. Did we just factor this in the previous slide? So 1 and 6 to work with, 2 and 3. I need to put the pair in here where I'd get a 1 of some sort. Yeah, we did this in the last one. So negative and plus, I think it was. And that works out. And so see how that looks? We already factored that in the previous slide. Here it is. And this is just a little different because we could factor out a 2 first. So we need to keep that in the answer. So that's it. Okay, this is a little different problem. Your problem, when you see it on the quiz and test, will just say factor. And see, take a look at it. There's 4 terms here. Is there anything I can take out of all 4 terms? Is there an x in common with all of them? Is there a y in common with all of them? Is there a 4 in common with all of them? There's nothing that is in common with all of them. So this should say factor by grouping because that's the method that we'll use. What we're going to do, and this is a common problem on YouTube, you could search for factor by grouping and you'll see this. This is a common problem in algebra courses. What we're going to do is factor these 2 first and factor these 2 separately. So if we just look at x squared plus 4x, what's in common there is an x, and then you write what's left, which is an x plus 4. Because x times each one of these will give me this back. So I'm always multiplying that back to check. Then you, as it happens with these problems, you always write down the sign that's right here. Whatever sign is there is what's going to work out. But you can see that by trial and error, supposed to. Maybe memorize that. Then you look at what's in common here with these 2 terms. There's a y in common. So I'm going to write what's left. It's actually an x plus 4. Because when you take negative y times x, you get negative xy. And you take negative y times 4, that's a negative 4y. And so see how that's x plus 4 is the same here? It should always work out that way. And you can just write it and see, because we'll be able to check our answer in the end. Now what we do is we're going to factor sort of these 2 terms as if they're 2 big terms. So you see what's in common with each? What they have that's the same is x plus 4, as odd as that is. And then what's left is x minus y, and you write it just like this. And that's the answer. If you just take those steps every time, you'll get it correct. And you can also FOIL first, outer, inner, last, which I'll do really quick. And you'll see that matches the original problem. It's just that these 2 terms are turned around, which is okay, same thing. So whatever you get, you can always check by using FOIL, because there are 2 binomials here, multiply, and check that it matches the original problem. Then your steps were correct. Now here's another problem. This is like an equation though, it's already factored with equals 0. Okay, so what you do is you take each factor and set it equal to 0, like this. And you're going to solve each. So x equals 2 here, and that's one solution. And then over here, x equals negative 3. That's how you're going to add 3 to something and get 0. Okay, so your 2 solutions, and that's it. That's really all there is to that. Because you want to know what's going to make this whole side 0, and then over here what's going to make that. So we take each one separately, set them equal to 0, and solve. Now here's an equation that we're going to solve. This is called the quadratic equation. And your quadratic equations look like your classic trinomial, usually. But you need to have that 0 happening on that side. So if you see a problem like that, what you need to do is move that negative 20 over to the left side by, adding 20 to both sides. That's what we would do to move it. And negative 20 plus 20 is 0, so that's all that's left here. So we write that 0. Now we have that classic trinomial setup equals 0. That's a typical quadratic equation, what we call. So what we're going to do to solve it is factor. There's 4 different ways we can solve quadratic equations. I think we cover just 2 of them here. So we're going to factor this. So we throw in x and x, remember that? And then we jump to the 20. And I'm going to write 20 and all the factors I have to work with 20. 2 and 10, 3, 4, 4 and 5, 5 and 4, which is silly to write that again. I'm not going to write that again. And I think I'm missing one, am I? No, when they're consecutive, that's it. So I'll erase this because that's kind of silly to write that. Did I miss something? I'm kind of sleepy. So now I need to put a pair of those numbers in here that when I multiply, I get a 20. But when I add or subtract them, I'll get a 9 of some sort. So I'd get a 1 or 20 or 19 or 21 here. I'd get an 8 or a 12 here. I'd get a 9 or a 1 here. So that'll work. So put the 4 and the 5 in. I consider my signs last. So I need a positive 20 when I multiply these, but I need a negative 9 when I add or subtract. So I think negative, negative. You can put in plus, plus, and FOIL and see if that works. So now I have to make sure I factored it correctly, x minus 4 times x minus 5. So you can FOIL somewhere real quick and check that, but I take my word for it, it is correct. And remember now what we do to solve for x, we take this one, set it equal to 0 separately, and then this one over here, set it equal to 0 separately, and solve each for x. So x equals 4 and x equals 5. So here's your two solutions right there. And what you can do is take 4 and plug it in everywhere you see an x here, evaluate and see if you get a true statement, and that if so, that tells you got it correct. Then take the 5 in, plug it in for x everywhere you see an x, evaluate and work it down, and if you get a true statement, then that's the correct solution as well. And this is the last problem. So you can try and solve this quadratic equation, right? The zero is already happening here, which is really good. And you can try factoring this. I'm going to actually use the quadratic formula so that I'll have covered that with you. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so now the general form, which I'll squish up in here, of a quadratic equation is ax squared plus bx plus c equals 0, okay? So in our formula we have a, b, and c's, so we need to identify out of our equation the a, b, and c. So we just look at, compare it to this general form. The a is the coefficient of x. There's nothing here. It's really a 1. So a is 1. Here, b, if you can see that, is negative 10, the number in front of x. C is just the number that's right here, but you do take the signs with these. So C is positive 16. Now that's what we're going to plug in here. Right under. Remember, I always write the formula, and then right under it, I write down every symbol and everything, every number that comes with the formula. And then I plug the A, B, and C in. So A is 1, that's easy down here because 2 times A is all you got down here. B is negative 10. So I plug in negative 10 right in for B. I'm substituting negative 10 right in for B. I need parentheses there. And then B here as well. So negative 10 is being squared. Minus 4 times A times C. So that's 4 times 1 times 16. Now I have to simplify this according to the order of operations. The bottom's always really easy to do. That's a 2. Negative negative 10 like that makes a positive 10. Plus minus the square root of. Negative 10 squared is 100. And then I'm going to have a negative 4 times 1 times 16. So basically 4 times 16, which is 64. And then I take that up here and simplify it further. I have a 2 on the bottom. I have the 10 here, plus or minus square root of 36, it looks like. We know the square root of 36 is 6, so I'll replace that with 6, doing one thing at a time. I think I'm going to need the next slide. So x equals 10 plus or minus 6 over 2 is what we had. So what you do here, since we have all numbers that are nice and simple, looks like we can simplify this. You'll have 10 plus 6 over 2 and work that out, and you'll have 10 minus 6 over 2 and work that out. So 10 plus 6 is 16 over 2. 16 over 2 is 8. So one of my solutions is 8. You can write that wherever or identify that in multiple choice. 10 minus 6 is 4. Got that over 2, and so 2 is your other solution. So you probably could have factored this because they came out as whole numbers. So you just simplify it as much as you can, but you should have multiple choice to be able to identify the answer. And that's how to use the quadratic formula. And definitely you can search in YouTube for solving quadratic equations using the quadratic formula and find lots of instructors explaining those. That's all the problems I have for you on this. So just remember that your assignments due by Sunday night are a quiz and a test. And you have YouTube and my math lab, especially. Those are the students' favorite resources for help. Other than that, that's it, guys. Have a good week.